Okay, welcome children. Today, in application of derivatives, we'll see an important concept, maxima and minima. Actually, to find the maximum and minimum values, that is to optimize a function, there are two different tests are there in our syllabus, in CBSE syllabus. One we call as the first derivative test, that is using only the first order derivative alone. That we call as for the first derivative test. And the second one we call as for the second derivative test. Here we'll be using the first order derivative and also for the second order derivative, that is f dash of x also will be finding and f double dash of x also will be finding. Okay, now most of the problem, all 6 mark question, mostly based on the second order derivative test only. Okay, now we'll see what are all the steps and what is the statement of the second derivative test. Everything we'll see in today's class. Okay, now see the second order derivative test. Let f be a function defined on an interval I and c belongs to I. Let f be twice differentiable at c. Okay, before applying the second derivative, we must be careful that the function is twice differentiable, that is f dash of x and f double dash of x also exists, then only we can apply this derivative test. Then the first condition, x is equal to c is point of local maxima if f dash of c equal to 0 and f double dash of c is what? Less than 0. The value f of c is local maximum value of f. So only x is equal to, second condition is what? X is equal to c is what? Point of local minima. See the first point, local maxima. If it is for the local maxima, the condition is what? F dash of c equal to 0 and f double dash of c equal to 0. Therefore, these two are the condition. If x is equal to c is a point of local maxima, f double dash of c must be 0 and f dash of c is equal to 0 and f double dash of c must be what? Less than 0. Similarly, see the second point, if x is equal to c is what? Local minima, then the condition is what? F dash of c is equal to 0 and f double dash of c must be what? Greater than 0. For these two conditions, for the first two, the function will have our maxima or minima only at critical points. We might have studied earlier. What is critical point? That is the solution of the equation f dash of x is equal to 0. If I solve f dash of x is equal to 0, whatever the points you are getting, suppose if I get x1, x2, x3, all these points, we may get 1 point or 2 point or 3 point or more than 3 point also we can get. Understood? Therefore, all these points we call as what? Critical points. All these we call as what? The critical points. Now we have to find the value of f double dash at these points x1, x2, x3. If that value is less than 0, negative, then that particular point is for the local maxima. That's what this first statement implies. Similarly, the second statement, after solving f dash of x is equal to 0, we'll get the critical points, then find the value of f double dash of the function at this critical point. If f double dash of x or f double dash of c is greater than 0, then that particular point x is equal to c is what? Point of local minimum. Therefore, you must remember, for maxima the condition is what? F double dash of c must be what? Less than 0. For minima, f double dash of c is what? Greater than 0, positive. Understood? Okay. Then we have what? Next question. Suppose if f double dash of c happens to be what? 0. What's the result? See here. The test failure, that's a third result. The test fails if f dash of c is equal to 0 and f double dash of c is also equal to 0. If f double dash of c becomes 0, then the test fails. We cannot say the point is what? Either maximum or minimum, we cannot say. Understood? Then what you have to do? Then again we have to go back to the first derivative test to check whether the point is what? Local maxima or local minima or point of inflection. Understood? Therefore, even the point of inflection could be found only using what? The first derivative test. The second derivative test, we cannot find whether it is a point of inflection or not. Understood? Therefore, the point of inflection could be found only using the first derivative test. If the point is local maxima or local minima, only then we can use what? The second derivative test. Okay, now we'll go. What is this concept say actually? What is this theorem says? That we'll see. Just I'll explain. Just this one, then I'll go forward the problem. See here, suppose if y equal to f of x, y equal to f of x is a function. We know that every function has a graph. Understood? Therefore, for the function y equal to f of x, if I take this is x axis and this is what y axis, y equal to f of x, suppose if it goes on like this. This is the function y equal to f of x I am taking. We know that every function definitely has what? A graph. Understood? Some standard graph, we know a linear equation or a linear function always implies what? A straight line. That's why it is called linear. A quadratic function will always represent what? A quadratic, a parabola. Like this we know, we have studied already all these things. Understood? Okay. Now we'll see. We'll come to our topic. Understood? Now here, see here, this is the curve y is equal to f of x. Here, the first one, see x is equal to point is a local maximum. See here, from here, I'll get what? Some points here. This point I am marking, for example, this one. This is one point of local minimum. From the graph, easily we can say which are all the point of local maximum, which are all the point of local minimum, all these things I can find easily. So this is point A, if I assume this is the point B I am taking, this is what points, and correspondingly here I am taking this is x is equal to x1, here this is x is equal to x2, and here this point I am taking as what? X is equal to x. Therefore 3 such point. Even it may have what? Many local maxima and local minima. We must be very clear that what is absolute maximum and minimum and local maxima and minimum. A function may have any number of local maximum and any number of local minimum, or sometime a function may not have a local maximum and local minimum, or some other function may have only local maximum but there will be no local minimum, and vice versa. But absolute maximum and absolute minimum is not like that. Every function has exactly only one absolute maximum and only one absolute minimum. That you must be very clear with that. Understood? Okay. Now we are talking with what the local maximum and local minima. When I come to what the absolute minimum, I'll compare and once again I'll say that. Okay. Now see here. Here we know the tangent, that is this point. If I take this x is equal to x1, that is if I take this point A, at this point if I draw the tangent to the curve, how the tangent will be? Definitely the tangent will be what? Parallel to x-axis. Definitely the tangent will be what? Parallel to x-axis. That's why here this f dash of x1. What is f dash of x1? That is nothing but the slope of the tangent. That is nothing but the slope of the tangent. In the previous section we have studied all these things. Therefore f dash of x1 is equal to 0. Therefore all these extreme points are all these critical points. This A, B, C we call as what? The critical points. See all these points, if I draw the tangent, definitely the tangent will be what? Parallel to x-axis. That's why the f dash of its slope will be what? 0. If a line is parallel to x-axis, definitely its slope will be what? 0. That's why f dash of x1 is equal to 0, f dash of x2 is equal to 0, and f dash of x3 is also what? Equal to 0. Therefore, if f dash of x1 is 0, f dash of x2 is equal to 0, and f dash of x is equal to 0, we call these points are what? Critical points. Therefore, A is a critical point, and B is a critical point, and C is a critical point. We call this is critical points, or turning points also we can call. All these points we call as what? Critical points or turning points. Anything, both are what? The same meaning. Okay. Now see the second condition. F double dash of C is what? Here on the left side of, I am taking now the first one. If I take A on the left side of A, how the function is? Can you see the curve? the curve is what goes on increasing. The curve is what goes on increasing. On the right side of A, see how the function, the curve is what goes on decreasing. Left side it is increasing. For increasing function or for increasing curve, what is the slope? See, suppose a function is what increasing like this. Therefore, if I draw a tangent at this, definitely the tangent will make an acute angle with the positive direction of x-axis. Suppose here if I take, suppose the function is what a decreasing function. If it is a decreasing function, if I draw a tangent to the curve, it will make an obtuse angle. Obtuse angle. Understood? This is nothing but the angle of inclination we call. Understood? That is, if I take this is theta 1 and theta 2. Since the angle is what an acute, what is tan of an acute angle? This is what positive. What is tan of an obtuse angle? Tan of obtuse angle will be what? Negative. Till 0 to 90 we call acute. Therefore, from tan 90 less than 90 degrees, that is what positive, and tan obtuse. That's why here, if I draw the tangent here, all the tangent will be what? Positive. Therefore, here the slope of the tangent is nothing but what? F dash of x. Therefore, this is greater than 0. In this interval, f dash of x will be what? Less than 0. If the function is decreasing function, if the function is what? A decreasing function, f dash of x is less than 0. Here the function is increasing function, f dash of x is 0. Therefore, f dash of x is greater than 0, then f dash of x1 is equal to 0. Again, f dash of x become less than 0. See, the function goes on increase, then afterwards, it at the turning point, it get the other direction, and now it comes down. Understood? This was the first derivative test actually. What is the first derivative test? That is f dash of x1 is equal to 0. At the maximum point, f dash of x1 is equal to 0. On its left side, f dash of x is greater than 0. On its right side, f dash of x is less than 0. This is what the first derivative test. But here we are not going to find whether the function is what increasing or decreasing, all those things. Here we are going to use, see here this concept here. Here f dash of x is greater than 0. Next is f double dash of x is less than 0. If f double dash of x is less than 0 means actually the curve is what? Concave downward. Actually it is not in our syllabus. This wordings, all those things, just I will tell this one, then I will go to the problem. This we call as what? Concave downward. When f double dash of x is less than 0. When f double dash of x is less than 0, the curve is what? Concave downward at that point. See here. Here, concave downward. What is meant by concave downward? This we call as what? Concave downward. This we call as what? Concave upward. Can you see this one? See here. Concave downward means like n. Concave upward means what? It will be what? Like u. Understood? That's all. Therefore, concave downward. This is what? Concave downward. And concave upward. Concave upward is like what? U. This is called as what? Concave upward. Therefore, here I will be getting what? Point of maximum. Here I will be getting what? Point of minimum. Understood? Therefore, whenever we have f double dash of x is what? Less than 0, then that point will be what? Point of maximum. And see, come to what? B. Here in B, f dash of x2 is 0 at that point. When x is equal to x2, at this point if I draw the tangent will be what? Parallel to x-axis. Therefore, definitely it is what? Critical point. Now we are finding what? F double dash of x. If f double dash of, at this point, f double dash of x is what? Positive. Here f double dash of x is what? Positive. If f double dash of x is positive, the curve will be what? Concave upward. Concave upward. If it is concave upward, then automatically the point B becomes point of local minimum. Point of local minimum. Okay. Here see again this one. Here this is nothing but here f dash of x is 0. But what about f double dash of x? Definitely here f double dash of x will be what? Less than 0. Since f double dash of x is less than 0, it is what? Concave downward. Concave downward. Concave downward means then the point x is equal to x3 is nothing but what? Point of maximum. That's all. Therefore, this is the condition. Understood? Okay. Then we have a doubt. How the point of inflection will be? How the point of inflection will be? Okay, I'll explain. Then I'll go to what? The problems will go. And also we'll see. See here. Suppose if I draw the curve y is equal to x cube if I take. If I take the curve y is equal to x cube. This is x axis. This is y axis. See what is how the graph of y is equal to x cube. I think you might have learned in 11th standard y is equal to x cube means what? The curve will be what, like this, it goes on. Therefore, this is y equal to x cube. Actually here y equal to x cube means that is f of x equal to x cube. But what is f dash of x? F dash of x is what? 3x square. Therefore, what is f dash of x? F dash of x become what? 0. F dash of x is equal to 0 means this gives x is equal to 0. Therefore, at x is equal to 0, this point if I take at x is equal to 0, see whether this point x is equal to 0 is what? Point of minimum and maximum. It is not minimum and maximum. The curve, it will not change its sign. This side f dash of x is what? Positive. That is increasing, no? Therefore, greater than 0. This side also f dash of x is what? Greater than 0. That is increasing. If the function, if the curve is what? Increasing, goes on increasing, the sign of f dash of x will be what? Greater than 0. Here it goes on increasing. Therefore, f dash of x is greater than 0 throughout this curve. Understood? Therefore, the function has no turning point. The function has what? No turning point. But here when I solve f dash of x is equal to 0, I got x is equal to 0 is what? One of the critical point I got. But x is equal to 0 is what? Not a turning point. Therefore, this we call as for the point of inflection. This we call as for the point of inflection. Understood? Okay. Now we'll see how to solve the problem of what this local maxima and local minima. Understood? Just we'll recall. Understood? The same concept, but steps how will you do? That's what we are going to see. What the next one? The next one, when we solve the problem, what steps we have to remember? What are all the things we have to recall? All those things we'll see one by one. Okay. Now listen. See the first step now. Steps to be followed for maxima and minima problem. The first step is what? First get the function to be optimized. That is whichever function to be maximized or minimized, that function we have to assume, and that function we have to get, that we have to assume as what? F of x. Maybe we may be maximizing the area of a square, or minimizing the perimeter of a rectangle, or minimizing the perimeter of the circumference of a circle, or maximizing the volume, or minimizing the surface area, whatever it may be, that we call as what? That function only we are going to what? Maximize, or we are going to what? Minimize. And so that function we can take as what? F of x. That function we are going to take as what? F of x. So for this, what are all we need? I must know all the mensuration formulas. What you have studied in our 10th standard. Understood? That is area, perimeter, circumference, surface area, and volumes. All these things formula. Understood? Mainly we have what? In our syllabus we have what? Square. We have the problem based on what? Square, a rectangle. Next we have what? Circle, circle and semicircle. Both we have circle and semicircle. And next one or two problems we have what? A triangle also we have. Triangle. Next is what? A cube, cuboid, all three-dimensional figure. Cube, cuboid, cylinder, cone, sphere, everything we have here. Therefore, all these formulas, whatever you have studied in 10th standard, just take and go through and make all the thorough these formulas. All easy formulas only. Once if I go through, you can recall. Understood? Circumference, surface areas, and volume, all those things. Surface area means what? We have two types of surface area. One is curved surface area or lateral surface area, and the total surface area. Either that is curved surface area or total surface area. According to the problem, we'll apply the formula, we'll get that. For this must be our first step. We must write this formula first. Okay, next. See here the next one, second step. Convert the function f of x completely in terms of one variable. This is very, very important. If you can do this step, then the remaining all The remaining all other things are very easy. Only the second step is what very important here. Understood? See, for example, the area. Suppose the area of a rectangle, if I take the area of a rectangle is equal to what? A equal to L into B. Here L is also a variable and B is also a variable. L is also a variable and B is also a variable. Understood? Therefore, this to be converted in terms of one variable, that's very important. Here we have two variables, but it must be converted in terms of what one variable, either in terms of L or in terms of B. Understood? That technique, if we understand, then the problem becomes what very easier. Only that you must practice. Remaining all other steps, remaining afterwards, whatever steps you are getting, that's what very easy step. Only the second step. See that what you do. If the function has more than one variable, from the sum some information will be given. That is the perimeter of the rectangle is what 35. Otherwise, sum of the length and the breadth is what 40. Some information guides. Therefore, something like this, if it is given, if the function has more than one variable, from the sum, find the relation between the variables and use. That must be used here. See, for example, here I told the area is what L and B. Suppose if it is given that the perimeter of the rectangle is what 50 centimeter. The perimeter is equal to 50 centimeter. What is perimeter formula? 2 into L plus B equal to 50. Therefore, what is L plus B? L plus B equal to 25. Therefore, what is B here? B is 25 minus L, or L is 25 minus B. That to be used here. That's all. Therefore, from the problem, or sometimes we have some standard relation. That is, if I take a right triangle or in a cone, always the slant height h square, L square is equal to h square plus r square. We know that. Understood? We know that L square is equal to h square plus r square. Therefore, that type of relations also can be used. Clear? Okay. Now see the third point. Solve f dash of x is equal to 0. Already we got a function which is to be optimized, which has to be what maximized or minimized completely in terms of one variable x. Understood? Now you solve f dash of x is equal to 0. That is, you find f dash of x. Then make f dash of x is equal to 0 and solve. Understood? Then get the critical points as x1, x2, x3 like this. How many, whatever points you get, write everything. Sometimes mostly may get what 1 or 2 critical points only will get. Understood? Therefore, solve f dash of x and get the critical points as x1, x2 like this. Understood? Okay. This third step over. This third step is what very easy. Just we have to find f dash of x, algebraic function. To solve, to differentiate a function, we know the product rule and quotient rule. All those things we know. Therefore, using those formulas, therefore just you differentiate and solve the equation f dash of x is equal to 0. Next, fourth step, find f double dash of x. Once again, find the second order derivative. Find the second order derivative. Right? Okay, that's a easy thing again. Again, last one, see, last one. Here, find the sign of f double dash of x at the critical points. Already we got the critical points here, x1, x2, x3 like this. Now we got f double dash of x. Now you find the sign of f double dash of x at the critical points. Suppose if the critical point I am taking as what? Xi. Then f double dash of xi is what? Greater than 0. Then x is equal to xi is what? Point of minimum. I told already. That's a second derivative test theorem. Understood? The theorem says that f double dash of x is greater than 0. Greater than 0 means what? The curve become what? Concave upward. Concave upward means what? This x is equal to xi become what? Point of minimum. Similarly, f double dash of xi is what? Less than 0. Then x is equal to xi is what? Point of maximum. Only this one you must remember. That's all. Understood? Greater than 0 means minimum. Less than 0 means what? Maximum. That's all. This is the concept. Understood? You know what is the second order, second derivative test, and also the steps to be followed for the problems of these kind of things. Understood? Okay. Now see once again.